My name is Szabolcs Horvát, and I'm a complex systems physicist who works with networks. Many systems in the real world, whether man-made or natural, have some kind of network structure which cannot be ignored if we want to understand their behavior. One example is the current pandemic, or really any epidemic. Already in the early 20th century, scientists have devised mathematical models to describe epidemic spreading, but these early models assume that any person can infect any other, which is of course not the case, because there's a contact network between us which really serves as the substrate of spreading. And now it is well understood that the structure of this network can have a dramatic effect on the outcome of the epidemic. This is the premise of the young field of network science, that structure in networks influences behavior or function. If we want to understand how a system with a network structure works, the first step is to describe mathematically the network. And indeed, network scientists have devised several analysis techniques to do this, but most of these only consider the network in an abstract sense, where network nodes don't have locations, as is sometimes the case, such as in social networks. But in other cases, like streets of a city or neurons in the brain, the nodes have specific locations, and those two nodes which are close to each other are more likely to be connected than those which are far. These networks are called spatial networks, and their structure is often strongly determined by the locations of their nodes. I work mostly with biological applications where such networks are quite common. I mentioned the networks of the brain, but vascular networks are another example. And we find that when we want to analyze such networks, applying classical methods doesn't give very informative results. We can maybe only read out from the data that these are spatial networks or something about the shape of the spatial domain where they exist, but not their local structure. Therefore, there is a very strong need to develop mathematical methods which are specific to spatial networks, and this is my project here, driven mainly by biological applications.